Greetings, mathematicians. This is Unit 7, Lesson 1, Simple Expressions. Our objective today, I will read and write expressions. Seems pretty easy. Read it one more time with me. I will read and write expressions. Now, the key word here is expressions. This is the most important term of this lesson. And as such, our vocabulary term is expression. This is a number sentence without an equal sign. Now, if we have one with an equal sign, for instance, 3 plus 2 equals 5, this is no longer an expression. This is an equation. The main difference is equations you solve, expressions, 3 plus 2, no equal sign, you simplify. And the real trick is solving and simplifying generally mean the same thing. All right, let's get some examples of expressions. And an expression could be any operation. So an example of an expression with addition would be 1/2 plus 2/3. An example with division would be 24 divided by 3. We could also have an expression inside, or an expression that uses parentheses. So it could be more than 2 addends or more than a dividend and divisor. It could have 3 different parts. So this one is a little bigger. Let's start with the number 5. 5. And you'll notice on this expression, we have parentheses. So I'm saying 5 times 6 minus 2. So what we'd have to do is start in reverse. What is the difference between 6 and 2 multiplied by 5? Some expressions might not have 2 numbers. Some expressions use algebraic variables or letters. So 6 plus n. It could be 6 plus n or n plus 6. They are interchangeable. Let's take a look at another multi-step expression. See if we can figure out where to begin. I've got 3 parts. I've got subtraction. I've got multiplication. We did work with this the other day. We talked about the acronym PEMDAS. Please excuse my dear Aunt Sally. Which would we do first, multiplication or subtraction? That's right. We would say the product of 10 times 4/10 subtracted from 12. So even though it is written left to right, we may solve it in a different fashion. All right. Let's take a look over here. How do you read expressions? Because that's part of our objective. How are we going to read them? So part of reading them is seeing them numerically and putting them into putting the computation into words. So addition is great because we could put either add first. We could say, well, let's start with the operation. Let's say add 3 and 5/10, and, because and is a joining conjunction, 6 and 3/10. Now we could very, very easily come through and swap the order here and say add 6.3 and 3.5. Either one is correct. Let's take a look at subtraction. Subtraction requires some order. And when we're looking at subtraction, we really want to look at the operation and after. So if we can pull that, we can look at the operation, subtract, How many? How many are we subtracting? Subtract 2 from 10. Now, of course, we could be using the number as well. Either one works. Subtract 2 from 10. So start with the operation, see what we're taking, and then we'll state where it's being taken from. Awesome. Oh, that should have been read. Whoops. All right, let's look at multiplication. Just like addition, where the add-ins could be reversible, the same is true for multiplying these two multiples. So we've got 1/2 and we've got a variable e. So we could say 1/2 times e. We could also say e times 1/2. We could also use the answer would be the answer to a multiplication problem is a product. So we could say the product of, remember, of and multiplication go hand in hand. Product of 1/2 and e. And again, we could reverse those two. Product would be the answer. Of always means multiply. And similarly to subtraction, we want to isolate the operation and what follows the operation. So we can say divide. Oops, dived. Let's try that again and spell it correctly. Divide 4. Well, that doesn't make sense. Let's read it left, right. 14 divided by 4. So divide 14 by 4. We could also say 14 divided by 4. Either one works. All right, let's take a peek at some samples. So an expression can be done in words. It can be done in numerals, in numbers. Let's take a peek on the next page. How would you write this subtraction expression? Seven 5/10, 2 25/100. How would we write that? Well, again, with subtraction, we can take it from the backside. So we could say subtract 2 2/5, 2 25/100 from 7 5/10. All right, next up, let's do an additive expression. Variable addition 9. How would we write that in words? Again, we could simply say add b and 9, or vice versa, 9 and b. Either one works. Next up, we have a multiplication expression, 3/4, multiplication symbol 8. There are a few ways to write this. What is one way that you know? Tried and true, 3/4 times 8. We could say 3/4 multiplied by 8. We could say the product of 3/4 and 8. All would work. All right, and our last expression to words, 16, division sign 2. I think the easiest route to write this would be 16 divided by 2. Awesome. And now that we've gone expression 2 words, let's go the other direction. Let's take our words and write them as expressions. Find the product. Ooh, product. This is the answer to what kind of problem? Find the product of, of is a clue. What's the clue? 12 and 2. What would the expression be? Now this could be 12 times 2 or 2 times 12. There is a commutative property that can be applied to this expression. All right, next up we have a subtraction problem. Subtract 2/3 from 3.5. We're going to focus on that. I'm sorry, I want to focus on that. Subtract 2/3. And we want to go from the other side. All right, next up, add 14 and t. And my conjunction is a dead giveaway. Simply 14 plus t, or t plus 14. Division is always a bit tricky. This time we're going to divide a variable by a variable. The trick is to look at the words and figure out which one is the thing being split up, which is being divided. So I could say B divided by A. All right. Thanks for watching.